Okay, so I'm going to take a look at doing a numbers version of a question like this one, a higher quadratic inequalities type of question. So the first thing I do before I start on numbers is I want to just solve this on paper and kind of generalize the question as well. So the first thing we're going to do for this is factorize it. So we'd have x plus 2 minus x plus 3 is less than 0. And so the roots would be x is minus 2 and x is 3. And we'll do the sketch. So there's minus 2, there's 3. Our graph is a negative x squared. And so we get that our function for this, f of x, is less than 0 when x is less than minus 2 or when x is greater than 3. Okay. So now we just need to go ahead and kind of generalize it first of all and then work out how we're going to program it into numbers. So the general type of equation that we're looking for is it'll be a question that will look something like, given f of x is equal to ax squared plus bx plus c for what values of x is f of x, and we'll either have it as less than 0 or greater than 0. That's kind of our options. Okay. So obviously for this, a lot depends on your roots and a lot depends on whether a is a positive or a negative. Okay, so we'll just kind of write down some of these ideas here. So if a is greater than 0, then we're always going to have a graph that looks like that. And if a is less than 0, then we're always going to have a graph that looks like that. And that's our roots here, p and q we'll call them. So there's a root p and a root q. So we want our roots to be have the names p and q. We don't want any repeated roots for this type of question. So we say that the roots p can't equal q, and we'll also say that b squared minus 4ac has got to be greater than 0. Okay. And if you think about it, that means if we say it's strictly greater than 0, we don't actually need to specify that p is not equal to q, because b squared minus 4ac greater than 0 takes care of that for us. Okay. So the next thing we're going to do, it's important that we can factorize it. And our factors, we want to have, I think for this type of question, probably our factor is going to be the building block of the quadratic. So we've used up a, b, and c, and p and q. So we'll call our factors what about gx plus h and sx plus t. Yep. So that means that our root p is going to be equal to negative h over g, and our root q is going to be equal to negative t over s. And we really want p and q to be integers. So we'll write that down somewhere. So where P and Q are integers. And we really, I don't think you'd want G or S, in this case, our values before the x's to be any greater than 3. So we'll say, and G and S in the range like say -3 to 3. Okay, I think that's pretty much all the information that we need before we can start programming the question. Okay, so let's go and see what we get in numbers. Okay, here I am in numbers now, and I've set up a higher maths folder, and we've got nothing in it yet, so let's go and create our first question. And we'll call it quadratic inequalities. Now, the parts mode is something I've not looked at properly yet, where you can either have the show all parts or the explore mode. I'll keep it as show all parts just now, and I'll look at explore mode later on. Okay, so we'll press create, and we've got our sort of question creation screen. And the first thing I'm going to do is I'm going to set up the variables. So if I click on the variables tab, if we look back at the question, we know we need variables of A, B, and C, and they're going to be the numbers that we use to make the polynomial, make the quadratic. We need roots P and Q, and we also need a Gx plus H and Sx plus T. We need a G and H and S and a T, okay? Because they're all the things that are going to change. So let's start from the end and work backwards. Okay, so the first thing we're going to do is G, H, S, and T. So G, and we said that the value for G is going to be between -3 and 3. We don't want it to be 0, so I should have probably put that in before, but I'm telling now. So it's going to be from any random number between -3 and 3 except 0. Right? We don't want it to be 0. And we want our S, we want the S value to be the same. So any number between -3 and 3 except for 0. Okay, you can see they've come up there, and we can click regenerate values, and they're just going to hover between those two states all the time. Okay. We also want values for H and T. We're not too bothered about what those values are. We don't want anything that's going to be too crazy, so I'll probably just stick to the same thing. Between -3 and 3, except 0. I mean, I guess you could have it as 0 in this one. Oh. But let's just keep it nice. And T, same thing. Okay. So that's just got our values for our factorised bit. We've got our values for what the factor is going to look like. Next thing we want to do is we want to use those numbers to create what our roots are going to be. Okay, so our root P we said is -h over g, so we just type in -h divided by g. and our root q is negative s over t. Okay, and you can see they're coming up, and they are coming up as fractions sometimes. Sometimes they're whole numbers, sometimes they're fractions. If we wanted to have them purely as integer values, we could do that. If we go into this variable testing tab here, that's where you can kind of put limitations on the values that you're getting. So if we click on that, the condition to satisfy is, now I think the code for this is int. If we click on the help menu and go to the function list, the function reference over here, then it will be number operations, I believe. Yep, here we have this function here is int. So it tests whether any number is an integer, right? And it returns, it always gives out a Boolean value, either true or false. So if it is an integer, then you get a true back. If it's not an integer, then you get a false back. And what we can do, we can use that to make sure that p and q are integers. So in this variable testing tab, the condition to satisfy is that we want your p and q to be always integers. We always want it to return true for them. So all we need to say is int for a value for p, and we should see now that if we do that, if we now regenerate values, every time we're doing it, p is always an integer, right? It never becomes a fraction now, okay? Now you can do the same for q if we want. So to put in another condition, we just type and to put in another condition, and int q, and that means that now our values for p and q are always going to be integers. Okay, and remember, we don't want p to ever equal q. It does just now, but we'll sort that out a bit later. Okay. This other bit, when we're doing this, if we hit this test condition, we can just check that the computer is going to be able to run with this. So we can see here, once we've tested it, it says that 30% of the time p and q are integers. So how this works is basically there's 100 runs, so the question regenerates itself 100 times, and out of those 100 times, the number of trials which have got integer values for p and q are counted. So out of the 100 times it ran this time, 30% of the times p and q were integer values, which isn't bad. That's fine. You can see if you want to allow at most 1 second to generate a set of variables, step max runs to 167. The device's chances of succeeding is 100%. This is kind of the wee bit. As long as this says this is 100% or close to 100%, well, you really want it to be 100%, then you know that it's going to work all the time. Okay, so we need to now generate our values for A, B, and C. And the way I'm going to generate them is just by multiplying out the quadratic. Okay, and before I do that, I'm just going to quickly go back here, just so I don't make any mistakes. I'm just going to multiply out the brackets here. So we'll have gs x squared plus gt plus hs x plus ht. Right, so A is gs, B is gt plus hs, and C is ht. So A is gs, oh, g times s even, B was gt plus hs, so g times t plus h times s, and c was ht. H times t. Okay, so this has got a bunch of variables there that we're going to use to generate the question. The other thing that we need to do is say whether it's going to be less than or greater than. So just make that, we'll call this less than greater than. It really doesn't matter what you call your variables. It has to be one single word, so that's why I'm using underscore instead of spaces. And if you call it something that you can remember, then all the better. Okay. And this we're going to make a list. We're going to have a list of two things, and that's simply going to be a less than and a greater than symbol. Okay, but a couple of things about this. So to tell numbers that we're making a list, I've used those square brackets, right? And then you can see down there, it then knows it's a list. Right? If we took them out, if we took out what was inside it, you can still see that it's a list that it's trying to create. It just happens to be an empty list. Okay, so if we put back in our values, we're making a list of the data type strings here, right? So whenever you use the inverted commas, that's telling numbers that you're putting in a string variable. Right? And we're going to use that to create our expression, which is going to be the main part of the presenting of the question. Okay, so the next thing that we want to do is write down our function. Okay, this I've said function here, that's just the variable name. Okay, and our function, the data type for it is going to be what we call an expression. And this is a really powerful thing in numbers, these expression functions. Because anything we put in this expression function now, we can generate it. It treats it as a mathematical expression, so it works using any algebraic manipulation you want. As long as it's in this expression formula, you really can do quite a lot with it. You can get it to present in latex quite easy and stuff like that as well. So we want our expression to be our quadratic, and that is going to be our value for a, which we'll put in those curly braces because that tells the numbers that we're putting in a variable, times an x, in fact it's not times an x, times an x squared, plus a b times an x plus our c value. Oh, we need to actually put the whole thing in inverted commas, that's what it is. Okay, so we've put the whole thing in inverted commas, and you can see down here it says generated value expression, and kind of value for this is 9x squared plus negative 6x plus negative 3. And that doesn't look exactly like we want it to do, to present as, but that is how we want to put it in as the expression just now, and that's going to make things nice for us later on. Okay. The other thing that we want to do is we want to have in this whether it's less than or greater than. Okay, so we need to some way of selecting less than or greater than, and I'm just going to call this toke, is just for a token. And we just want to pick these at random. And this list here starts at 0, so we've got an entry at 0 and at position 0, and we've got an entry at position 1. So I'm just going to say we want this to be a random number between 0 and 1, right? Or we could just make it a random number of the choice of 0 and 1 if we want. We'd write like that. Okay, so that's just going to go between those two. And then to actually select the value from the list, from the less than greater than list, then we shall say selection, I'll just call it selection. And that's going to be random. No, it's not going to be random, sorry, at all. It's just going to be from the list less than or greater than the value, which is at the position of whatever the token is giving us, right? So this is tokens at 0. So because tokens at 0 in the less than or greater than, the list at position 0 is less than, our selection here is less than. Okay. So if we go back to our function now, we can put that in there. So we want to have, our first bit of expression is this, and then we're going to have next to that whatever our selection value is. In fact, you know what we need to do for that? We need to put this separately, kind of build our string separately. Plus selection. And you can see it's saying not enough arguments for the operation greater than. It's changed to greater than now. Because it's saying this equation that we set up doesn't make any sense. We need it to be greater than something. So it's always going to be greater than 0, so we can just put in plus 0. Okay. And that's has got our expression now. It says minus 1 x to the power 2 plus 2 times x plus 3 is greater than 0. Okay. And we've got this selection here of the greater than or less than. We've chosen it this way because we are going to use this. We're going to be using it later to kind of define what our answer is. But for just now, let's go and see if we can get the statement up and running properly. Okay, so if we go to statement, we'll say given the function, and if we just put it in as in curly brackets, function, that is then telling numbers to look for the variable function, for our function variable here, and to stick that in our statement. If we click on preview just now, you can see that we're getting our function up. It doesn't look nice at all, but it is working. Okay, so let's make it a bit nicer looking. And the way to do that is we want to turn it into a latex function. So if we just do latex inside the curly brackets so that it's a kind of numbers type thing, and then put function inside normal brackets. If we do that now, it should start to look a whole lot nicer. Okay, you can still see it's not doing the simplifying stuff that easily. It's not changing the formula to a form that we would normally write it as, but it's starting to look a bit better. Okay, you can see like a lot of the issues are that if there's a plus minus, or if there's a 0 kicking about. There we go, plus 0x, we wouldn't normally write that. There's a whole bunch of simplification rules in JME. Okay, so if we have a look at these, I think it's substituting variables into displayed maths. This is again in the help section. You can see the simplify command, and there's a whole list of things you can simplify. Okay, a lot of the time you just need to put in all, so we'll show you how to do that. if we go back to our variable, to our expression, how we're going to write this is we're going to do simplify our expression, close the brackets, and again, we need to put in a second bit here, so we're just going to put in a comma, and then we're going to put in the open brackets to make it like a list. You can see now it's happy it says, well, we've done the simplify expression, we've got our expression in there, and we've also got a list. Then we're also going to put in all in inverted commas, and that should simplify using all of the simplification rules. So every single rule in here is then getting used. And if we just test that again, go back to our statement and go back to preview question, we should see now that here we've got a negative x squared, so it's not going plus and minus x anymore. If we had one with a 0x, like this one here, it's just leaving it out, okay? But obviously we don't want that, because that's a situation that we wouldn't be too happy with for this type of question. I suppose we could leave that in, but we do still need to put in a wee bit of code to make sure that we're only getting values for b squared minus 4ac which are greater than 0, and again that should be straightforward enough. We go to the variable testing tab again, and in here we're going to do and b squared minus 4 times a times c is greater than 0. Okay, and that there will only be true, this kind of statement here will only be true for values where b squared minus 4ac is greater than 0. Again, if we hit test condition here, so now we're down to 24.8% of the time. That's still fine because we've still got 100% of succeeding, so we're happy with that. Okay, so again, if we go to our statement now and just hit it a few times, these are all quadratics that we know are going to work for this type of question, right? So that's us got our question up and running. If you like, that's the easy part. Then the next part we need to think about is how we're going to do the answer. So for the answer for this type of question, let's make up a new variable, and we'll call it answer. So if our a value is greater than 0 and the selection value is also greater than 0, the selection value is greater than, then we're in this situation where, let's say p is there and q is there. So in this case, we'd want our answer along the lines of a value for p, x is going to be less than p, and x is going to be greater than q. Okay, so that's the first kind of option. If our a is greater than 0 and the selection is a less than, then our x value is going to be in between p and q. So we're going to have p is greater than or equal to q, x greater than or equal to q. Okay, then if a is less than 0 and the selection is greater than, then we're going to have Again, the same as the last one. X is going to be in between P and Q. And the last option is that if A is less than 0 and the selection is also less than, then we're going to have this kind of thing where we want this bit and this bit. So that's going to be where X is less than P and X is greater than Q. Okay. So this is going to take a wee bit of thought about how we're going to actually program it into numbers. Okay, I've gone away and I've had a wee think about how the best way to do this particular one as an answer would be. I think the best thing to do is kind of have it as a multiple choice. We'll give 4 answers each time, and we'll get the person using doing the question to select one of the answers. I can't really think of another way of getting it to work that would be better. So anyway, for our answer here, I've started off putting it in as a list, and I'm going to make it a list of strings, and that covers all the options. Okay. So the first option was that X is less than P and X is less than Q, is greater than Q, sorry. So we'll just write that as X is less than our value for P and X is greater than our value for Q. Right, and you can kind of see down here that it is, because we've got the curly braces around the P and the Q, it's taking it as a variable, so it's saying X is less than 1 and greater than -1, which I'm not too keen on because that means that they're swapped the wrong way around. So there's something wrong. I think the bit that's in my logic that's wrong is that, P and Q, it doesn't really matter which way they go round, but it always has to be, I guess that P is going to be smaller than Q. So we need to do a wee bit of messing about with that to get that to be always the case. So what we'll do, I'm going to add a variable. I'm going to call it sort P and Q. And there's a function called sort, which sorts a list, but obviously P and Q aren't actually a list just now. So we need to tell it that it is a list. So we put the square brackets in to tell it's a list, and in that list we want P and Q, and that should mean that P and Q are always going to be sorted inside this variable here. So when we're doing our answers now, we can't just use P and Q because we always need P to be the smallest one, so we need that to be sort PQ, and it's the first thing in the list we want this bit to be. So sort PQ is 0, and we want this bit to be sort PQ1. Okay, so now you can see that -1 and 1 is always the first one that is going to be the lower value, which is going to be first. Okay, again, we can regenerate the values, and you should always see now, no matter what you're getting, you're always getting the lower value first. Okay. Okay, so the next part of our list is that when P is in between, X is in between P and Q, sorry. So we'll have sort PQ 0, and we want to put that in curly brackets, sorry, because it's a variable, is, now we want this to be less than or equal to, so we're going to use backslash LE for less than or equal to. Okay, hopefully that should work. Oh, we need a plus in there as well, actually. Now you can see how here it says coming up LE. That's going to be fine when we turn it into an expression, but just now we just kind of need to leave it as is. Then we need to also do we don't want the plus here, just want a space. In fact, you know what, we need 2 backslashes. We need 1 backslash to say that it's going to be less than or equal, and we need another backslash to say it's a special character. Okay, so the next thing we need to do is x, and then we need to do a space, and then we need to do backslash less than or equal to, and then we need to do sort PQ 1. Okay, and in fact that is all the options we need, because there is only, out of these 4 possible answers, either x is less than p and greater than q, here and here, or x is in between p and q, here and here. Okay, so we can just use if statements to make sure that we're selecting the right answers. Okay, and I'm going to change the name of answer to answers because there's more than one. Okay, and then I'll add another variable, and we'll do, call this select answer. Okay, now this is where we need our something to specify the 4 different options. We've got lots of different options. If it was just 1 or 2 options, we could use an if statement. Because there's lots of different ones, we're going to use a switch statement. Okay, so the switch statement works that you've got, you know, the possibility 1, then the answer 1, possibility 2, the answer 2, and then always got a default statement at the end. Okay, you always need to have the default statement. So we'll do switch, and we'll say the first one is if our a value is greater than 0 and our selection is greater than 0. So we'll say our a value is greater than 0 and our selection, in fact we'll say token is 1, right? So our token which chooses less than or equal to, when it's 1, it's greater than. Okay, and so when that happens, what we want our answer to be is the first option. So that was answer 0. Okay, so that's the first bit done with, and I'm going to put this on a new line just so that we can see all the different options. Okay, when a is greater than 0 and our token is 0, we want this to be answers of 1. When a is less than 0 and our token is 1, I just want to double check what this one was. When a in selection is greater than 0, that's the in between one. That is answers 1. And we want our default case now. The only thing that's left is, so that's just going to be answers 0. Okay. And that gives us a string which should give us an answer for each possible thing. So it gives us one single answer, which is a string for every situation that we need. Okay, and you can see that it's kind of working how we want it to be. The only other thing we want to do really is turn this into an expression. And we could turn it into an expression in this bit here, which I think we should do. So to turn this into an expression, we just put the word expression before it and put the rest of the thing in brackets. Okay. And it doesn't like it. Okay, so the next thing that I'm going to do is we need to make up a multiple choice options for this question. We've already got two options here, and obviously only one of these two is going to be correct for any given case. What I'm going to do is make a couple more options for this that are always going to be wrong, so that there's 4 options to choose from in every question. So we'll just put one which is x is greater than the first root and x is less than the second root. And we'll make one more option where x is, let's see, less than the second root and x is greater than the first root. Okay, so now we've got 4 different options that are going to be displayed when we get to putting the multiple choice part in. Okay, so the next thing is we need to actually go and put in the multiple choice part and get a display in. And we do that through the parts option. So we've kind of got all the variables I think now that we need, as far as I can think. Maybe need one more. And we'll go to parts and we're going to put in choose one from a list. Choose one from a list, this bit here. So that means that we can say what the list is, and then we can pick an answer which is correct, and then the person running the program has to pick the right one. So this is the area where we're doing that, and then we get this bit, the prompt is, that's where the question is, and let's see. Let's see, for the statement, for the bit of it, choose which of the following is correct. Again, we'll probably come back and change the wording of it at the end. We're going to put in their choices, and our first choice, I always put in the first choice as the correct one. And so to make it sure it's the right one, so we go back to our variables. It's just whatever select answer is. So it's just string, and it's just select answer. Okay. And we remember that the select answer is chosen from the list of answers. Okay. So we just go into choice 1, and it's a variable, so we put it in curly brackets, and we'll just say select answer. Okay, and let's just check my spelling's right. Oh, variables, select answer, that should work. And this is the one that's going to be correct, so we want that to be the number of marks that you want for the question. Let's just make it 1 just now. Okay. Now, we obviously don't want the this is the correct answer being chosen again, so we need to actually make up a new variable, and this is going to be answers without correct option, something like that. It's not the catchiest of names, but what we can do from that, again, I need to go to the help bit for us and go to my list of JME functions, and in here in the function reference in the list part there is a function that lets us take out one from a list. So I think it's remove I think it's this one. No, it's not. What does that do? Take the first n elements. No, we don't want that. Filter might work. Yeah, I think we'll go for filter. So this filter, we can put in an expression to start, and then we can that should let us filter out what we're looking for. So let's just try that. Is just sorry, this is just a wee bit of picking the right function. So the one that would be better. I think it must be filter. So we'll go for filter, and filter, and our expression is that we want the value inside our select answer, our answers list. So our answers list, we don't want that to be equal to the select answer. And our list is answers. So let's just check that that's worked. So our select answer for this one is that x is in between -2 and -1. And so the new list that we've got is that x is -2 and x is greater than -1, x is greater than -2 and x is less than -1, x is less than -1 and x is greater than -2. So we've got those three options, and that seems to have worked and filtered out the correct answer. So this is now a list of wrong answers. Okay, so that's what we want, because we want to put them in the different choices. Okay, so we'll add a choice and we'll go back to our list of variables. It was answers without correct option. answers without correct option, and we'll put the first one of those in there. I'm just going to copy this, and then we'll add one for the second option. There's always going to be three options. There's always going to be three options, so we do 0, 1, and 2 for this to get three options. Okay, and that should be that. The other thing we're going to do is shuffle the order of choices, so it's not always the first one that's correct. So in this bit here working, they'll only get 1 mark that's tied to the select answer thing, but when it presents itself, they don't know what order it's going to be in necessarily, but the select answer will always be tied to the one with 1 mark. We can change if we want it to be radial buttons or a drop-down list. I think we'll keep it as radial buttons. We can have it as going sideways or presented as a column. Let's make it a column. It'll probably look a wee bit better as a column. We don't want a custom marking matrix. Okay, so now if we run it, we should see that's presenting. It's not presenting quite right yet. So we need to do a wee bit of work on that. I think what we need to do is just a string that is doing us. So we need to do it. We need to put it as a latex function. So just write latex and put it in brackets, and then this as well. And this as well. Okay, so now if we run it, hopefully it'll be presenting a wee bit better. It's looking a wee bit better. We've not got a space between the ands, so we need to do that. So that's in our variables, and we'll just go to our list with all of them in it. That should be the bit there. Let's put it here. For this bit, it's probably to get a space between the ands. Let's see if there's a latex function. So we'll just use that for backslash space. We'll try that. Okay, and let's see if that works. Nope. Oh, might need 2 backslashes. No, that's still not working. Right, so let's try another option. What we can try is to separate this out a bit. We could try putting that in there, plus another inverted comma, plus another inverted comma, plus an X. So that's us kind of forcing it to have a space in there, hopefully. And now if we run it, let's see if that's any better. Nope, it's still not displaying properly. we can try something like this. We'll try a medium space first of all. So let's get back to where we are. So we need 2 backslashes and a colon. Let's try it now. Yep, that looks like it's worked, this one here. You can see that there's a space now between the -1 and the and. So we can hopefully put that in. Okay, that looks a bit better now. Now we just really need to say what the question is going to say, because just given the function, choose which of the following is correct. So it's not really a question here. So if we go back to parts and then go to the prompt bit, let's change this. So we've got given the function, then whatever the function is. Then we can say for what values of x and let's make it a latexy x, so we can do that by putting it in dollar signs. Is the function and we want to put in a variable here, and it was, what do we call that? Our selection. And the function is, or say is f of x and then selection, because that was our variable that held the plus or the greater than or less than symbol, and we need a 0 after it, and we'll close the brackets. Let's just preview this. Oh, yeah, you know what, we need to do it this way. We'll do that, and we'll do that. You can see it does switch between the two. So what I've done there is I've put the f of x as in dollar signs to make it a latex f of x, and then I've closed the dollar signs to make it just that bit, and then we say to the computer we want to choose a variable here, so we put that in curly brackets, and then we want to have a latexy 0 there, just to make it look consistent. Right, there's not going to be much difference. See if we take away the dollar signs here. You can see there's not much difference, but the 0 is a wee bit nicer looking than if you do it as a latex 0. Okay, so now if we run this, given the function minus 4x squared minus 2x plus 2 is greater than 0, given the function, we'll need to do a wee bit of messing about with the actual statement now. So given the function f of x equals, and if we go back to our variables, to our function, we don't really need this greater than 0 bit in here. There we go. So if we run it now, hopefully, we should have something. So we've given the function f of x equals 3x squared minus 3 for values of x is f of x greater than 0, and then you can do it, and we'll reveal the answer. So if we solve this, it would be your roots are plus or minus 1, and x squared is positive, so it should be less than minus 1 and greater than 1. Huh. Oh, put an empty, yeah. It's picking the wrong. I just picked the wrong one. Okay, so it seems to be working. All right. Okay, and that's it. That's that question.